Hi, welcome back to Moose and Chemistry. This is Nuclear Chemistry Half-Life Lesson 3. Again, half-life is defined as the measure of time that it takes for a radioactive sample to decay to half the original amount of the radioactive material. Again, there are two different types of half-life formulas. Personally, I prefer this one. Mathematically, we're more used to doing it. But if you want to use this one, more power to you. It's the same thing, it's just using different variables. First question, how many half-lives of gold-198 will pass after 36.2 days? Au-198 or gold-198 half-life is 2.69 days. Okay, well, knowing that, all we have to do is this. We know the number of half-lives, so half-life basically, to figure out time, you would do T over T1 half would equal X. So in other words, if you know your time and you know the length of the half-life, you don't have to go through all of this right here. Because that's when you have a sample, for example. So you would just go, X would equal, we know their days, 32.6 divided by 2.69, and I'm just going to put days out here because that's what it's going to be. And then you simply do the math, divide the two together, and you get 12.12 days. I mean, it works just that easy. Really, seriously. Okay, if a sample of 200 grams of Einsteinium-240 undergoes 7 half-lives, how much would be left? Well, okay, no problem. In this case, you are going to use y equals, say, x 0.5 T over T1 half. Well, guess what? We have 7 half-lives, right? So all we have to do is go y equals 200 times 0.5, and this would be a 7. This T over T1 half is going to be 7 because we're given that information. Okay, so y would equal 200 times, so let's go ahead and take 0.5 and raise it to 7 half-lives. Okay, and that gives me, well, let's see here, 0.007, 8125. Okay, you multiply that by 200. And that gives me approximately 1.56 grams of Einsteinium-240 left. So after 7 half-lives, you go from 200 grams down to 1.56 grams of Einsteinium-240. Well, that's it. You guys be snarly, and we'll see you back here at Moosing Chemistry.